In the following, we are going to give the first definition, the very first definition in the lecture notes. And this is going to be the definition of a formula. You can see the definition on your screen now. But first, let's talk about it. Why such a definition is important? It is important because it specifies very, very precisely how to formalize logical statements, also known as formulas. How can you build up correct formulas? How can you build up syntactically correct formulas? This means that everything in those formulas are used in a correct way. Like you use conjunction with two operators, left-hand side and the right-hand side, or you use the negation in front of a formula which you want to negate. Anyway, syntactical correctness is very important, not only in logic, but also in general in computer science. Just think of programming. When you use a programming language, you are probably not aware that the correct syntax of those languages, those programming languages, is precisely defined in advance. It is defined, for instance, how to use a for loop in Java, how to define a function in Python, or how to declare a variable in C#. These are all precisely defined in advance. And this is important. Otherwise, programs could not be compiled or interpreted and executed at the end. So in a similar fashion, we precisely define what a formula looks like. And here it is. You can see the definition. How does it start? So it first introduces a non-empty set V of Boolean variables. Just remember what you did when formalizing English statements in logic. This is what you did. You, in advance, introduced your Boolean variables, actually a set of your Boolean variables. And you, of course, needed at least one Boolean variable. So this set is not empty for sure. Okay, then let's construct our formulas. Let's start with the simplest one. What a simplest formula looks like? Well, of course, if you use a single Boolean variable, this is already a formula, a statement. So use a Boolean variable is the simplest kind of formula possible. So this is what you can see here in the first item. If you take a Boolean variable a from the set of Boolean variables, then this is already a formula. Done. Okay, what's next? Well, let's start using the connectives we have learned about. We learned about 6 connectives. Negation is the easiest one because it has only one operand, and this is actually defined here. So if you take a formula A, which is already a formula, a statement, then you can put the negation operator in front, and what you get is also a formula, of course. The rest of the formulas, such as conjunction or implication or XOR, and all those 5 operators we got to know, are so-called binary operators. They have 2 operands on the left-hand side and the right-hand side. Of course, those 2 operands must be formulas, must be statements. Let's just take 2 formulas and connect them with any of those connectives here. So you put the chosen operator between the 2 formulas, and also you have to use parentheses around them. What you get is also a statement, also a formula. Yeah, so that's it. This is a very easy definition, a very typical definition. You start with the most basic, the easiest case. What you define what the simplest formula looks like. And then you define the more compound cases. If you have already defined, already built up a formula, or even two formulas, how you can build up a more compound formula from them.